Hi, good morning. Myself Sheikh Yazin. And my project is a hybrid approach to optimize irrigation timing and quantity based on environmental and crop data. And I'm going to explain this project now. Agriculture, like this one, second slide. Yeah, reduction. Agriculture consumes about 70 percentage of the water, fresh water, and the most fields still follows static schedules that easily over or underwater. Our aim is simple delivery, adaptive zone-wise irrigation, advisories, and the response to real conditions in the soil and the sky. And on the right, the story top of the bottom, we start with an NDVI field, and weather cues. Those our IoT and our remote sensing streams, they feed to modeling paths and a tree baser or learners for heterogeneous tableau and signal the sequence to learners from seasonal and seasonal rhythm. The orange function conjunction fusion node are like temporal tableau hybrid, that is robotic tableau and operational, and two principles to guide the system: first reliability and second recoil. Today I will show the result comparing the random forest xgb boost and our hybrid lstm plus xg boost, and why the hybrid best aligns decisions with real dynamic real field dynamics. And I'm going to explain root problem and gap. There is a rule based schedule or transparent, but they are locked decisions to fix thresholds. When the soil and weather more quickly, those rules can adapt. So we miss right movements to irrigate. So move clockwise direction. There's like clockwise direction to achieve the shale pure ML or line rich non-linear patterns. So but we can overfit our PAQ, and farmers need decisions. They they must trust and challenge, to black box and bottom left, the clock with the leaf. Most tabular modules ignore time, diurnal and seasonal rhythms, wet dry lags, and recovery periods that how get right amount of water at the wrong time. The dolet or in the middle of the gap, none of them alone. Decision timely, acoustic, and calculated and expressional. Our requirement is clear, combined temporal learning and tabular reasoning, validated by zone and time, and the deliver cabinet probabilities with the recall, away thresholds, and interpret reports. And our research objectives and contributions. And on the other side, I will continue what we aim achieve. We are actually build the bullseye. It's our project is 70% course really means 7 or tons or irrigation our need. The magnetic wave drops in our second optimized recoil. We rarely miss true irrigation event. Sorry. All three streams flow into funnel yielding one accommodational LG boost the thresholds. Then dataset feature engineering. Yeah. Here's our raw, because raw becomes model ready. Start at the top of the diagram. We integrate sensor streams. We integrate the sensor stream, soil moisture and temperature, humidity, weather is like VPD and the rain. And imaginary induced NDVI, NDRE, those flows in mute. We do median fill, and the mission. What the hell is this one? Machines flag per features, then encode categories and scale. So distant learning. So now, so next we add time. We build 24-hour step window and encode our hours and day of year. Sin consign and dumps capture journal and seasonal. We then create the agronomal interactions with the NDVI into NDRE. Then net effect, then less noise, preserved physical meaning, and the temporal signature, and the determine when verification should be happen. This is a methodology or project how working. That's how system works end to end. We start then top drop, ingest and clean impute include like and time and lag features. This gives us constant and leak free table 24 step sequence per zone. Then we run and then we run three modeling branches in parallel. A branch one random, or like a random forest, our stable in interval baseline for feature importance and quick diagnosis. Branch 2 like a XG boost. Branch 3 is LSTM. This was used, which looks like 24-hour sequence to capture diurnal and short seasonal rhythms that tableau. Finally, we stack them in small logistic layer. Everything on right and side mirrors. They flow from sensors through pre-processing into three learners and out irrigation recommendation. And let me these models. Yeah, let me simulate the three models: random forest and XGB boost and hybrid LSTM plus XG boost. And random is our sturdy baseline, dozens of base trees voting together. Clear feature importance is one. And XG boost goes further. It builds three sequencing correcting errors each other, which gives best precision recall for Tableau data. And the hybrid LSTM and XGBoost adds what both miss temporal circles and 24 hours window of zone history. And evolutional protocol. And this shows how to make the true worthy. This things graphics evolution compacts with 4 points: north zone CV with group K fold by zone. So entirely filled together the skills, spatial leakage, skills, spatial leakage. The model never sees a plant from same zone. The both test. Can I go to explain results? How results However, starting with a baseline random forest deserves a solid benchmark accuracy 0.958 and recall 0.902, F1 0.844, ROC AU 0.981. It depends and interpretable but misses more true integrations. XGB boost pushes tabular performance accuracy 0.93963, precision 0.984. 78, sorry, I have to recall 0.980, F1 0.871, PR AUC 0.782. After astronomic aberration in probabilities or real barrier 0.0282. Our hybrid LSTM exhibit boost accuracy 0.964 recalls. Yeah, then we go to the slide. A comparison and interpretation. Think of this triangle is our trade-off map. Each corner is a priority. Each corner is a priority calibration on the top, experience of the left, and the temporal robustness recall on the right. Exit boost on the side closest to calibration. It gives most reliable properties, and random walls lends towards the explainability. And hybrid LSTM plus XGBoost is pulled towards temporal corner and highest recall of 0.987. Then challenges and mitigations and conclusion. Let the walk with throw rail lenses, flywheel like this one, realizes resilience, flywheel, turn real world problems into reliable decisions. First, the challenge field sensors and noise is sometimes missing. The target is imbalanced. We risk leakage if some zones appears. Our data heterogeneous, our temporal sequences plus static. Now the mitigations for noisy sensor with medium implementations, machinist indications and rolling smoothness. And then outcomes and the right payoff, calibrated properties, high recall, favor missing integrations, and the reliable model that runs at the edge. In the short, each weakness has paired control, and weak keeps turning a new data arrows. The simple trustworthy irrigation advice. And there's a conclusion for my project. Thank you so much. Hope I think so. It's Thank you so much, sir.